Everyone, this is your math guru. In this video, I'm going to show you how to simplify the following trigonometric expression. In the first example, in 9.1, we have sine squared theta divided by sine of 180 degrees minus theta multiplying cos of 90 degree plus theta plus tan of angle 45 degrees. I'm going to extend my fraction by a sin. I'm going to start by simplifying the denominator. So I leave the numerator as it is, that's sine squared of theta. And then for my denominator, using my cast diagram, for my cast diagram I have C, A, S and T. In the first quadrant we have theta or 360 degree plus theta. Second quadrant I have 180 degree minus theta. The third I have 180 degree plus theta. And in the last quadrant or fourth quadrant I have 360 degree minus theta. So I'm going to check in which quadrant this sine 180 minus theta falls into. That's going to be in the second quadrant. And if you look at the second quadrant, sine is positive. So that becomes sine of theta times cos 90 plus theta. Using my cofunction, I have cos of 90 degree plus theta equals minus sine theta. So that becomes times minus sine theta, and then using my special triangle for 45 degree, I have, if this is 45 and this is 45 degrees and this is a right angle triangle, the short sides 1 1 and then the hypotenuse is root 2. Tan is opposite over adjacent, so that's going to be 1 over 1. So that's going to give me 1. So that's half plus 1. Simplifying further, that will give me sine squared theta divided by sine theta times minus sine theta, that's minus sine squared theta plus 1. The next step, I'm going to use identities to simplify what I have in my denominator. I have cos squared theta plus sine squared theta equals to 1. Therefore, cos squared theta will be equal to 1 minus sine squared theta, which is what I have in my denominator as sin. So therefore, replacing minus sine squared theta plus 1, I will have sine squared theta divided by cos squared theta. The next step, I'm going to use another identity that states that tan theta equals sine theta over cos theta. So therefore, sine squared theta over cos squared theta is going to be equal to tan squared theta. So I've been able to simplify what I have, the trigonometric expression, into tan squared theta. Let's look at the second example. For question 9.2, please don't forget to click on the like and subscribe button below for more easy to understand math concepts. I have sine of 104 degrees in bracket 2 cos squared 15 degrees minus 1 close bracket divided by tan of 38 degrees multiplying sine squared 412 degrees. I'm going to use my reduction, starting with sine 104 degrees. That's going to be equal to, if you look at my cast diagram, 104 degrees fall into the second quadrant. So that's the code I'm going to use. That's 180 minus theta. So for me to have 104, I'm going to change that to sine of 180 minus 76 degree, because 180 minus 76 will give me 104 degrees. And then if you look at this expression, That is my double angle. My angle in this case will be mine 15 degrees. So if I change that, that's going to be multiplying cos of 2 times 15 degrees divided by, so for the double angle, I'm working backwards. Then if I go to the bottom, tan 38 degrees, I'm going to change my tan using my identity into sine 38 degrees divided by cos 38 degrees, because tan theta equals to sine theta over cos theta times, I have sine squared 412. So I'm going to reduce my 412 by taking out 360. So that's going to be times, I'm going to put this in a big bracket. I have sine of 360 degrees plus, to make 412, that's 52 degrees, all squared. Don't forget to square that. And if you look at the quadrant that falls into, that will be the first quadrant, and sine is positive in the first quadrant. So if I rewrite what I have, my expression becomes at the top, because that falls into the second quadrant, and the second quadrant sine is positive, so therefore this expression sine 180 minus 76 will become sine of angle 76 degrees. Then I have my double angle, and to expand or simplify further, 2 times 15 is going to give me cos of 30 degrees. At the bottom, I'm still going to maintain my sine 38 degrees divided by cos 38 degrees times, then I'm going to simplify what I have in my bracket. Sine 360 plus 52, that falls in the first quadrant, so that's sine being positive, that becomes sine of 52 degrees. So rewriting that, I have sine of 52 degrees all squared. Simplifying further, sine 76, that's double angle. So to change that, the clue is looking at the value I have in my expression to see how I can write my angles in similar value. And because at the bottom I have 38 degrees for my sine and cos, I can as well change 76 degree into a multiple of 38. So if I rewrite my sine, I have sine of 2 times 38 degrees, because 2 times 38 will give me 76. Then I have times, for my cos 30, using my special angles, that's root 3 divided by 2. I'm going to try and simplify my denominator. I still have my sine of 38 divided by cos of 38 degrees times, now I have sine of 52 degrees. Using my cofunction, or to change that into 90 degrees minus 52, I'm going to find a value whether if I subtract from 90, it's going to give me 52 degrees, and that's 38. And look at what is happening. I'm still maintaining my 38 degree as I have in each of my values. So therefore, sine 52, I'm still going to put that in the bracket, will be equal to sine of 90 degrees minus 38 degrees, all squared. That's equal to, I have sine 2 times 38, that's double angle, and using the double angle identity, that's equal to 2 sine 38 cos 38 degrees times root 3 over 2 divided by, I still have my sine 38 degrees divided by cosine of 38 degrees times, now I'm going to work with what I have in the bracket, that's sine of 90 minus 38. Using my cofunction, that's going to be cosine of 38, and because it's squared, that's going to be cos 38 degrees all squared. So therefore, simplifying now, I have 38 cos 38 divided by cos 38, and the square cancels out. Then the cos 38 will cancel the one in the numerator. Then I have sine multiplying or dividing sine 38 degrees for my numerator. Then I have my 2 dividing 2. So what I'm doing is taking out common factors at the top and at the bottom. And what I'll be left with is square root of 3. Thanks for watching. Bye.